This is Mrs. Lewis's classroom, and let's talk about your science fair project proposal. Today is Friday, September 14th. So this video is for you if you weren't here, or if you were here and you just need to remember a couple of things. On Google Classroom, you will see that I have the project proposal pulled up for you and that each student will get a copy. So just like when we do our Google Classroom bookwork in class together, it's the same type of format. You're going to open up the document. You'll come in, you'll fill it out. You'll put your name. If you have a partner's name, okay? And then you're going to go in and you're going to just start typing in all of your information as you should. When you're done, you will have a little rectangle that looks like this, but it's not blue and it doesn't say share. It's gray, about this color or this color, and it says turn in. So just like the Google Classroom documents, you're going to click turn in. Your proposal is due to me by Thursday of next week, which is the 20th. I do have a late turn in, which is Friday the 21st, but you have to have that turned in through Google Classroom no later than Friday at 3 p.m. This is because on Saturday it's going in front of our first committee for our safety, and then on Sunday it's going in front of our scientific committee. If you do not have it turned in on time, you're going to have to wait until the volunteer committee reconvenes, which could be at least a week away. So whatever you do, don't wait and get it done ahead of time. So if you told me you were going to be gone ahead of time, you already have this packet and you're able to get started. If you did not tell me you were going to be gone, or an absence that was last minute that couldn't be helped, you need to come in and pick up a packet first thing Monday morning before school starts. So first things first, you need to highlight this. Complete and turn in through Google Classroom by no later than Thursday the 20th. And of course, we do have Friday as an option. Each exhibit needs to have a title, and we had some students last year, and one of their titles for their exhibit was Mission Impossible. Have fun with it. Why not? Name of participants, your first name and your last name. So for example, if your name is Elizabeth, no matter what your nickname is, you still need to put your actual name on your birth certificate. Here, please. If you have a partner, their name, first name and last name will go here. If you do not have a partner, then you'll just leave it blank. We already spent a day talking about hypothesis and all the different variables that are involved in an experiment, but included in this packet are a couple of things, and I want you to highlight and underline and add the different things that I have added as well. So what is a hypothesis example? Well, a hypothesis is what you're trying to prove. And here's some actual student examples from West County. Number one, if we change the environment of an animal so its camouflage was no longer effective, the population numbers would decrease. Notice we have shown our cause and we have shown the effect. It is a statement and it is not a question. So, back to your project proposal, your hypothesis, here's your hints. What are you testing? What do you predict will happen? This is the box where you're going to make that statement. No questions are allowed, and you have to show cause and effect. What is a scientific principle? Well, it's that thing that's going to make your project legit. The laws of science, also called scientific laws or scientific principles, are statements that describe or predict a range of natural phenomena. Each scientific law is a statement based on repeated experimental observations that describes some aspect of the universe. And here's some examples. The first one, the 4 principles of adaptation. The second one that was used, the first law of thermodynamics. And we have the first and second laws of thermodynamics. On your science fair project proposal, we have a space for the scientific principles. You can include a theory or a law. It doesn't have to be a law. You may use a theory, for example, Newton's first law. This is where you will write it. This is an aspect of your science fair project that you are going to have to research. I'm not your Google. However, if you get stuck and you have 2 or 3 that you think are very closely related, I will help you in that aspect of determining which one is the best theory or law. I can also point you in the right direction, but I cannot do the research or the work for you. What are methods? This is what you will do in your experiment. So here's some examples from last year's science fair. Research on animals, camouflage mimicry in different biomes. We'll use Freyer model, camouflage artwork, and photographs. Ice will be placed in a cup, box, etc. We will measure initial temperature and then in 15-minute intervals. I will fill all the water bottles with the same amount and same liquid substance and attempt to create motion, then collect data and repeat the same method again using different liquids. These were actually all really great methods. You don't want to give us a play-by-play. We don't need to know every single step for this section of your proposal. But what we did have missing and what we want to make sure that we add this year are these things. We need to be pointing out to the people looking to see if our proposal can be accepted or denied. Does it have an independent variable, a dependent variable, a constant, and a control? And this would be a great example of showing that. How about a constant, using the same water bottle every time, using the same amount of liquid? What about our independent variable, which is using the different liquids? What about our dependent variable? What are we measuring? We're measuring the motion. So make sure that you're naming those things while you're giving your 3 to 5 sentence method. So once you've determined that, you're going to come back to your science fair project proposal and you're going to give a loosely based, not step-by-step description of what you'll be doing in your experiment, and you will make sure that you name what each of those are. Next, you need a brief description of your materials. I don't need to know every single last items. For example, I don't need to know you need 8 batteries. I just need to know you need batteries. Maybe it's AA battery. I need to know if you're going to be using electricity. If so, what kind? Do you have anything that may be prohibited in the rules? Did you check it for safety? All of these things need to be included. Next, how long will the experiment take you to complete? From purchasing the items, building it, testing it, and to your final conclusion. Will that be 7 days, 10 days, or 3 weeks? A good rule of thumb is that as students, you need to be done with your experiment, completely done with the experimentation process, 2 to 3 weeks before your deadline of December 7th. Once you have turned this in through Google Classroom, I will print them off Friday the 21st at 3 p.m. and I will look through them Friday evening and either approve it or deny it. If it's approved, it will go to the safety committee, and once approved by the safety committee on Saturday, it's going to go to scientific review committee. I will have these back in your hand on Monday. Again, this is not something you want to be late on because you will be at least a week behind until the group of volunteers can get back together. Included in your packet for your proposal is a science fair project proposal outline, a rough draft. This is, like I've explained in previous classes, more complicated than the one that I just showed you and the one I want you to fill out. But some of us like to have every single last detail. If that's you, you will enjoy this. If it's not you, just skip it. Don't throw it away because you're going to need it later. Included in your packet are a couple of student examples. I know you all know what a quilt is, right? It's a bunch of little scraps sewn together into this beautiful pattern. Well, that's what we're doing. I'm giving you bits, chunks, and pieces, and at the end of 2018, we're going to put it all together, copy, paste, copy, paste, copy, paste, and you're going to have something that looks a lot like this. One of the things as a scientist that we look at, and I really look at, is what is the weakness? Are you able to self-evaluate your proposal plan, your experiment, during the experiment and post-experiment? I believe that we fail forward and that we fail forward to success. So this is something that the judges will be looking for and asking you about. So be prepared to evaluate yourself. Failing is not a bad thing as long as you learn from it and you move on to new successes. And finally, I do a lot of work through my email. You should be checking your email 2 to 3 times a week. Email me with problems, questions, solutions, anything having to do with science fair. If you can't stay after school, email me, and that's a way we can communicate. Or save it for Friday. But just remember, on Friday, you're competing with all of the other students in the classroom. So to have that one-on-one or that smaller group interaction, email and tutoring after school are your best bets.